Hi there. This interview simulation focuses on cloud regions, availability zones, and real failover strategies. The goal is to test how you think about high availability, resilience, and the trade-offs that come with building for reliability in the cloud. Before each answer, pause the video and say your response out loud as if you were sitting in a real interview. It is the best way to practice under realistic pressure. If you want more long-form DevOps interview simulations like this, subscribe so you never miss the next one. Let's start with a few warm-up questions. Tell me about a time you had to deal with an outage that was caused by a cloud provider rather than something your team did. A strong answer would sound like this. We had an availability zone issue that impacted our storage layer and caused widespread latency. Since it was not in our control, our job was to contain the impact. We shifted workloads to the healthy zones, activated our failover routes, and communicated clearly with stakeholders. It taught me that even with a managed provider, you need your own resilience strategy. Next question. Describe a moment when you realized your failover plan was incomplete or unrealistic. A solid response would be, our team believed we had a solid multi-zone strategy, but a real incident showed otherwise. Our database had zone affinity due to a hidden configuration, so it could not fail over cleanly. It forced us to audit every component and make sure the design matched the documentation. That experience taught me that failover runs need to be tested, not assumed. Another question. Tell me about a time you advocated for higher reliability, even though the business did not initially see the value. A thoughtful answer would be, I showed the business how downtime impacted both revenue and trust. Instead of pushing technical details, I highlighted payouts, lost sessions, and real user frustration. That helped the team agree on investing in multi-zone deployments and better monitoring. Reliability is easier to justify when tied to user experience. Next question. How do you handle disagreements in the team about how much redundancy is enough? A strong response would be, I focus on what failure modes we are trying to protect against. Some teams want 3 zones, some want 2 regions, some want global. There is a real cost trade-off. When everyone sees the actual risks and the actual costs, it becomes easier to choose a balanced level of redundancy rather than rely on gut feelings. One more warm-up. Tell me about a time you had to perform a failover under pressure. What did you learn? A strong answer would be, I learned that confidence comes from practice, not theory. During the incident, even small delays in communication created confusion. Afterward, we created repeatable runbooks and clearer ownership so the next failover would feel more like a procedure and less like an improvisation. Let's move into the technical questions. Explain the real difference between a region and an availability zone. A strong answer would be, a region is a geographic area, while availability zones are isolated data centers within that region. Zones give you protection against local failures like power outages, hardware issues, or cooling problems. Regions protect you from larger failures like fiber cuts or regional disasters. Real resilience means understanding the failure boundaries and placing your workloads accordingly. Next scenario. Your application is deployed across 3 availability zones, but all traffic is flowing into only one zone. What do you investigate first? A solid response would be, I look at load balancer configuration. If the target groups or health checks are misconfigured, traffic may concentrate in one zone. Then I check whether the other zones are failing health checks or scaling incorrectly. It can also be a misalignment in autoscaling groups that causes uneven capacity distribution. The priority is understanding whether this is intentional or an accidental bias in the configuration. Next question. You need to design failover between 2 regions, but the database cannot replicate asynchronously without the risk of data loss. What trade-offs do you consider? A strong answer would be, synchronous replication gives you strong consistency but introduces latency and tighter coupling between regions. Asynchronous replication gives better performance but may lose recent writes during a failover. The right choice depends on business tolerance for lost data versus slow performance. Sometimes the answer is to separate read and write traffic or redesign the schema to reduce cross-region dependencies. Next scenario. an availability zone in your primary region goes down. Failover works, but the remaining zones are overloaded. What steps do you take? A thoughtful answer would be, I scale horizontally in the healthy zones, check whether the auto-scaling rules are aggressive enough, and temporarily reduce non-critical workloads. If possible, I shift some traffic to another region to reduce pressure. A zone outage usually means the remaining zones need headroom, so part of the fix is adjusting the design so the system can survive losing a full zone in the future. Next question. Your team wants to run everything in multiple regions for safety, but leadership thinks it is too expensive. How do you decide the correct level of redundancy? A mature answer would be, I align the strategy with business impact. Not every system needs multi-region. Some systems can tolerate downtime or rely on backups, while others require near zero interruption. I categorize workloads by criticality and reliability targets. That lets me propose a tiered architecture where only the truly mission-critical systems need multi-region complexity. This balances reliability with cost in a realistic way. Next scenario. Your company wants to move to a multi-region architecture, but your stateful workloads depend on a storage system that does not replicate across regions. How do you approach this limitation? A strong answer would be, I start by identifying what data is truly critical and what can be reconstructed or cached. Not all state needs cross-region replication. For databases, I evaluate whether we can use read replicas, change data capture, or periodic snapshots to bridge the gap. If the application requires strict consistency, I consider redesigning how state is stored to reduce cross-region coupling. In some cases, moving to a distributed database or splitting traffic by user geography can solve the replication issue. The goal is to fit the architecture to the actual needs rather than forcing a tool that cannot support multi-region reliably. Next scenario. A latency spike appears across your application because one of your services accidentally started sending requests to a different region. What is your debugging approach? A thoughtful answer would be, I begin by confirming the traffic path. Tools like tracing, logs, and metrics will show where the requests are traveling. Once I confirm that cross-region calls are happening, I check DNS settings, service discovery, and any environment variables that define endpoints. Cross-region calls often mean a misconfigured URL or a missing local endpoint. The fix may be as simple as correcting a configuration value, but I also verify that the architecture has protections like region local routing to prevent this type of issue. A failure boundary only works if services respect it. Next question. During a high-traffic event, one availability zone starts throttling resources because it reached its capacity limits. Your application is deployed across 3 zones. What do? A strong answer would be, I shift traffic away from the overloaded zone by adjusting load balancer weights. I also trigger scaling in the healthy zones if there is room to grow. If the cloud provider is unable to add more capacity in that zone, the best option is to reduce reliance on it temporarily. Long-term, I would adjust auto-scaling policies to ensure that the system maintains enough buffer in each zone to absorb a full zone outage or slowdown. Cloud capacity constraints are real, so architecture must acknowledge them. Next scenario. Your failover test shows that failover works, but recovery back to the primary region takes a long time and sometimes introduces inconsistencies. How do you improve this? A mature answer would be, failover and failback are 2 different processes. Many teams design failover without designing a clean return path. I would start by making sure the primary region is always ready to receive traffic. That includes verifying replication health, database consistency checks, and ensuring that infrastructure can scale quickly. Then I would automate as much of the failback process as possible, including draining traffic, syncing data, and validating health. The goal is to make failback predictable instead of risky. Next scenario. Your system is designed for multi-zone resilience, but one of your services still has a hidden single-zone dependency. You discover it only after a zone outage breaks the service. What steps do you take? A solid answer would be, I perform an architectural audit of every dependency. Hidden single-zone dependencies often come from caches, legacy components, or services that were deployed before the move to multi-zone patterns. I redesign the service to use zone-independent storage or replicating caches. I also introduce chaos testing that simulates zone failures regularly. If the goal is true multi-zone resilience, every component must be able to lose a full zone without breaking, and testing is the only way to be sure. Final scenario: you need to choose between active-active multi-region and active-passive failover. The team is divided. How do you make the decision? A strong answer would be: I look at the consistency requirements, latency sensitivity, and operational complexity. Active-active gives great durability, but requires a distributed architecture that can handle conflicts and partitioning. Active-passive is simpler, but can involve longer recovery times. If the workload cannot tolerate conflicting writes, or if complexity outweighs the benefit, active-passive may be the better choice. The decision is always grounded in the business impact, not just technical preference. Let's move into the pressure section. These scenarios are ambiguous by design and reflect the kinds of decisions engineers have to make when availability, regions, and failovers are involved. Here is the first scenario. A full regional outage occurs in your primary region. Your secondary region is healthy but has not been tested with real production traffic in months. Leadership is asking for an immediate failover. Do you switch traffic now or validate the environment first? A strong answer would sound like this. User impact determines the urgency. If the primary region is completely down and users are stuck, delaying too long makes the situation worse. I switch traffic to the secondary region but monitor aggressively during the transition. At the same time, I validate critical services as they come up. Ideally, this validation would have been part of regular testing, but in a crisis, the priority is restoring service quickly while being ready to roll back if the secondary region shows issues. Next scenario: your multi-zone architecture suffers a partial outage in one zone. Metrics indicate rising latency, but the zone is not fully down. You can drain traffic away from it, but doing so may overload the remaining zones. How do you make the call? A thoughtful answer would be: I examine the trend rather than the snapshot. If latency is rising steadily and service degradation is likely, staying in the failing zone risks a full outage. I would begin shifting traffic away while simultaneously scaling up in the healthy zones. If scaling is limited, I may temporarily shed non-critical workloads or reduce feature load. The decision comes down to choosing controlled degradation over an uncontrolled failure. Next question. You discover that a core dependency in your system is deployed only in one availability zone, even though the rest of the system is multi-zone. Migrating it is risky and time-consuming. Should you leave it as it is or push for a high-risk migration? A strong answer would be: a single zone dependency undermines the entire reliability model, but high-risk migration needs careful planning. I gather data on the failure probability of that zone, the impact radius, and the operational cost of a migration. If the service is critical to uptime, I advocate for a safe migration strategy, possibly involving blue-green deployments inside the same region or incremental replication. I avoid rushing it, but I do not accept single-zone dependencies for long-term production stability. Another scenario. You are asked to design a failover strategy for a system that has strict consistency requirements and very low tolerance for downtime. Leadership wants multi-region, but the technical constraints make perfect consistency across regions nearly impossible. What do? A mature answer would be: I surface the trade-offs clearly. Strong consistency and low latency often conflict with multi-region reliability. I would propose alternative patterns such as active-passive failover with synchronous replication inside a region and asynchronous replication across regions. Or I would suggest decoupling critical data paths from less critical ones, so only the parts that require consistency stay local. The goal is to create a design that respects physics, not one that tries to ignore them. Final pressure question. During a failover test, you discover that your DNS provider updates more slowly than expected. Traffic takes much longer to shift between regions than your planned recovery time objective. Do you change DNS providers, adjust your architecture, or modify your objectives? A strong answer would be, I first verify whether the slow propagation is inherent to the provider or caused by configuration like high TTL values. If the provider is truly the bottleneck, I consider alternatives like Layer 7 routing, global load balancers, or traffic steering that do not rely solely on DNS propagation. Changing the provider might help, but improving the architecture often gives more reliable control. Objectives should reflect what the system can realistically achieve, but I try to improve the system before adjusting expectations. Before we wrap up, take a moment to reflect on this interview. Designing for availability is never about perfection. It is about understanding failure boundaries, knowing how systems behave during outages, and making calm decisions under uncertainty. Think about which scenario challenged you the most. Was it the untested region, the partial zone failure, the single zone dependency, or the consistency trade-offs? Let me know in the comments. And if you would like more long-form DevOps interview simulations like this, subscribe so you do not miss the next one.